Yeah, China will ban to. China will ban to is everywhere, right? Let's call this hand.
Distinction.
Distinction. Yeah, so China ban to is everywhere, man.
China about to everywhere. China about to everywhere.
Everywhere.
China about to
Exactly.
everywhere.
Thanks.
Hello, how you doing, man? I'm Hamish, so let's get started here. I don't want to waste no time. So, obviously here, the sensitivity of a God is of a gold equal to 0.44 times 10 power negative 8 ohms meter, okay? At the room temperature. In room temperature, excuse me, the gold wire that is 0.9 millimeter in diameter, okay? And 14 long, okay? So we have that wire, which this is diameter, and this is how long it is, okay? And there's a current of 94 milliampere. So first and foremost, let's see how much power is dissipated in the wire. So now, let's assume this is a board wire. Let's say this is some type of wire. Okay, so this wire here, we have a length 14 centimeters, so 14 centimeter. So first and foremost, I'll change this centimeter to meter. So if you want to change centimeter to meter, you just divide by 100, which is going to be 0.14 what? Meter. And another thing also, okay, so this resistivity is constant. So the sign that will represent resistivity is this one here. Resistivity equal to 44 times 10 power negative 80 ohm meter. And another things, they give us diameter. The diameter we have means the diameter of this, all of it, because this is cycle, or this is like the whole, because this is a wire, means the diameter of all this stuff equal to 0.9, so 0.9 millimeter. So we're going to have to change that diameter of it to meter. So this diameter, if you want to change to meter, means you have to multiply by 10 power negative 3, so it's going to be meter. But remember, I don't just need diameter, I need what? I need radius. So radius, to get radius, take the diameter. So we get radius, take diameter divided by 2. So our radius is going to be, if you take that one divided by 2, it's going to get us, okay, divide diameter divided by 2, and this is going to give us 0.45 times 10 power negative 3 meter. Oh, so we have a radius, okay? So we have all the information. And the current too, the current right here. So this current equal to 9,400 milliampere. So we're going to divide by 1,000 because we just need as ampere. Okay, so if you divide by 1,000, this is going to be 0.94 what? Ampere. Okay, so we got all that we need. So how much power is dissipated in the wire? So we know the formula of power. Power equal to current times potential difference. That's a power. But also, I can split that and say, okay, so current, potential difference from Ohm's law equal to current times resistance. So I replace this current times resistance. But this one is current squared times resistance. Okay, so that's a power. So now let's look. Do you have a current? Oh yes, we have a current. We have a resistance? No resistance. So the issue here is to get resistance, okay? But we're going to use a formula for resistivity to get resistance. So resistivity equal to RA over length. Resistivity equal to resistance cross-section area. Do you have resistance? No, excuse me. So now, our intention, we're looking for what? For resistance, because current we have to get power, okay? So it's to get power dissipated. Is here power dissipated? Not okay? So now let's get resistance. So I'm going to make resistance the subject, so resistance equal to resistivity times L, resistivity times length over area. Okay, so do you have resistivity? Oh yes, we have. So resistivity equal to 0.44 times 10 power negative 8, which is given, times, do you have a length? How things we have a length. Length equal to 14 centimeter, but we change it to meter, so it became 0.14. This one right here, length. Yes, we have divided by 1,000. Now, okay, do you have a cross-section area? No, we don't have. But how do you get cross-section area? So cross-section area, because look, cross-section area is easy because I'll say cross-section area means this area here, which is circle, equal to pi r square. So our cross-section area equal to pi 3.14 times radius. What is the radius? 0.45 times 10 power negative 3. So our cross-section area equal to, you can plug in the calculator and you're gonna get something. But for now, let me plug you how it is here. Is the whole cross-section area. So cross-section area is pi r square, which equal to 3.14 times 0.45 times 10 power negative 3. But it must be what? Square here. Because r square, right? The square. Okay? You know what I'm saying? So take the calculator, plug in the calculator, and this is going to give us a resistance. What is our resistance? 5.37. 5.37 times 10 power negative 3 ohm. After we plug all of this. Oh, so we have our resistance. So since we got our resistance, then we can get our power. Let's get our power. Very easy, man. So what is the power dissipated? You know what I'm saying? So the power dissipated equal to current. Do you have a current? Oh yes, we have. We divided by 1000, which became 0.94, because you see this current is milliampere, so it has to be in ampere. So divided by 1000 is going to give 0.14 in there. But it's current square. So this must square here, and then you multiply by resistance, which is we just got now, which is 5.37 times 10 power negative 3. So finally, our power, what is our power? Our power equal to 5.7. 5.7 times 10 power negative 3 watt. Oh, so this is the power dissipated in the hole in the wire. Okay? So we already have a power. Now we want to go and get determine the electric field in the wire. Electric field in the wire. This is very easy, man. So now electric in the wire. So I'm going to raise this part here. Okay, we want to get the electric field in the wire. Okay. So we want to say, okay, let's get the electric field in the wire. So there is two methods of solving this. So I'm going to say electric field, so for number 2. So this was number 1, number 2 electric field. Electric field which you represent by E, always you take potential difference over the distance of separation, mean the length where the electron or charge of quantity they pass. But also electric field, it could be given as a force over quantity of charge. But for this case, we're not dealing with the force, okay? So we're not dealing with the force, we're not dealing with the quantity of charge. So we deal with the quantity of charge, but I'm not dealing with the force. So I'm not going to use this formula here. I'd rather use this one right here because of the nature of the question. Do you have a potential difference? No, we don't have a potential difference. Can you get it? Oh yes. So now I'm going to say, so I'm not going to need this. Potential difference from Ohm's law is say current times resistance, and the over length of distance of separation. Distance of separation for this case is length. Like how length is that? That's the distance of separation of the whole of this wire. You know what I'm saying? So now, do you have a current? Yes, we have. Do you have a resistance? Yes, we have. Do you have a length? Yes, we have. So we can get electric field. So I'm going to say, okay, what is the current? Our current is 0.94. 0.94. And then multiply by resistance. Resistance equals 5.7 times 10 power negative 3. And then we over length. The length equal to, divided by 100 is 0.14. So this is going to give us electric field. What is electric field? Our electric field for this case equal to 4.7 times 10 power negative 3 watt. So this is our electric field that you're looking for. Okay? But sometimes there's another way how to do it. Okay? There's another way we can solve this equation at the same time. So let's say I don't want to solve this way here. Okay? So I'm gonna say, so I'm gonna raise, right? But this is a final solution. Let's say I don't want to solve using this way. Okay, okay. So if I don't want to use this method, okay. So first and foremost, okay. I'm gonna raise this, right? Okay. Let's say I don't want to use that method in solving. Okay. So I'm gonna start from here. We look for electric field. Electric field equal to potential difference over D by potential equal I R over L. Okay? But then, let me come and replace this R. You know why? Because from here, I can get R from the resistivity. So resistivity, we say always resistance times cross-section area over length. Let me make the R subjects, and come substitute there. Okay, let's make the subject. So if you make R the subject, it's going to be R A times 1 is RA, and then resistivity times L is resistivity, cross multiplication. And then divided by A is going to be over A. So this is our R. So where this R is going to go? This R is going to come in here. So I'm going to say, okay, so I have a current, okay, resistivity, resistance equal, should be meant to say resistance equal to resistivity times L over A. And then all this stuff, because this is only that, over L. So you see this and this cancel. So now, our electric field equal to only current times resistance, because this and this cancel. Current times resistivity over area. And you plug it in, it's going to give us the same answer, because all this data here have. So now my electric field equal to current equal to 0.94 ampere times resistivity 2.44 times 10 negative 8, and then we over cross-section area. Cross-section area means pi r squared. What is the r? If this was all diameter, we did already, we have to divide it by 2, which is going to be 0.45. But we have to change this to meter. It means meter 10 power negative 3, and then square, because that's going to be pi r squared. So if you plug in the calculator this, it's going to give us electric field equal to 0.036 voltage per meter. So easy like that, man. It's just a waste of time. When you do this question, it is easy like that, man. Thanks a lot. You know what I'm saying? Look, man, I believe in learning from how to do things. If first time, make sure you subscribe, and you know, you can just go and do donation to our Patreon page. I have a Patreon, I have a GoFundMe. You know what I'm saying? I have all the means of donation, because to make this project going, you know, any type of donation, the little that you think is too small for you, it could make a lot of change. And thanks a lot for all your time. You know, subscribe, don't forget, share this video, circulate to a lot of people, you know, because the meaning of this project, this program, is to help as many as we can. Okay, it's not only for one patient or two, because you might think it's not helpful for you, but for somebody next out there, it could be very, very helpful. So thanks a lot, man. And you know, any donation that you did to me, it means so much. I appreciate it, man. It means a lot. Go to our Patreon page, go to our GoFundMe, because we need to have a lot of things. We need to put them together, like camera, you know, and a lot of equipment, so that we can improve on, you know, a lot of angle, a lot of aspects of these projects, you know. Thanks a lot, man. I appreciate and I love you. Peace and love. Bye. You know, this is one of my students of knowledge. You know, she wanted to introduce herself. What's your name? Could you please introduce yourself?
My name is Kali.
Yeah.
I go to Salisbury Primary School.
Yeah, I'm trying to combine school.
Trying to combine.
Trying to combine just everywhere, right? So this is my other student. His name, what's your name?
Matthew.
Matthew, yeah, he's grade 11, man. So his aim is to score distinction, right? So you promise I want you to score distinction this time. And what's your name?
Joshua.
Joshua, how much you promise me to score this time?
Distinction.
Distinction. Yeah, so I'm trying to combine just everywhere, man.
I'm trying to about you. Everywhere. I'm trying to about you everywhere.
Everywhere.
Trying to about you
Exactly.
everywhere.
Thanks a lot, man. Appreciate it. Thanks so much. If you had to give advice, Which advice would you give to the people or to the students?
Trust Hamish.
Why would they trust me?
No, because it's really good. They actually has helped a lot. I redid first year for maths. It was my own fault, but also I didn't know a lot of the work. And Hamish said lots of hard questions, and it's demotivating sometimes to look through the harder stuff. You like just want to get done, but it's the hard stuff that makes you realize the easy stuff is easy.
Sing with me and say